so here's the feedback on the final exam. Question 1. On January 1st, 2020, Lori invests P dollars in an account that pays a nominal annual interest rate of 5.5% compounded quarterly. The amount of money in Lori's account at the end of each year follows a geometric sequence with common ratio R. So a couple of things. First of all, compounded quarterly means that there are 4 periods. Okay, so there's 4 quarters in a year, so there's 4 periods. At the end of each year, so that means that Lori's going through the entire year, and so our time periods are going to be integers. Okay, so 1 year, 2 years, 3 years, because she's starting on January 1st, and we're looking at the end of each year. Okay, so one of the formulas that we have is the compound interest. There it is. So when we studied this in class, I really didn't like the way that the book presents the formula because of the 100. So you have to keep in mind that this 100 is because they're taking the percentage and making it into a decimal. So if it's 84%, 84 divided by 100 is 0.84. So I really don't like that way of presenting it. I'd rather just that you know that R has to be given as a decimal, but this is the way to present it. Okay. So this is the formula that we're really going to be using. Okay, and notice that the only thing that is changing is the n, depending on the year or on the number of periods. So for for like 1 year, n would be 1. For 2 years, n would be 2. For 3 years, n would be 3, right? So what we're multiplying each step is really 1 plus r over 100k to the power of k. This is the number that we're multiplying in each step, and that's the common ratio. Okay, that's the number that we're multiplying each step. So let's figure out what that is for our problem. So we have 1 plus r is 5.5 divided by 100. I'm just going to write it as a decimal, 0.055. Okay, over k. K is the number of compounding periods in a year, in this case 4, and then raised to the power of 4. Okay, this is the common ratio. You have to be careful not to confuse the common ratio notation R with the nominal annual interest rate. Okay, they're using the same letter, but that doesn't mean that they're the same thing. Be careful. You need to always make sure you know what you're talking about. So R in the formula is talking about the nominal annual interest rate, while R in the problem is talking about the common ratio. Okay, and of course we need to plug this into our calculator. So let's take a look at how that would look. So 1 plus 0.055 over 4, close parentheses, raised to the power of 4. 1.05614, etc. But it's asking for 4 significant figures. So make sure that you always take into account if they give you an instruction. Okay, so 4 significant figures is 1.056 because the next number is a 1, so we round down in this case. Okay, so these are my 4 significant figures. Now, if the problem didn't give you this instruction, then you need to round to 3 significant figures. Okay, and that's an instruction that is always in these exams that we have talked about, and it's something that a lot of you had some trouble with in this exam. Okay, so this would be part A. All right, part B. Lori makes no further deposits to or withdrawals from the account. Find the year in which the amount of money in Lori's account will become double the amount that she's invested. So, how can we solve this exercise? There's really two ways of doing it. One is to do it, by hand, and another one is to use the application in the calculator. So let's do it by hand first. So we're going to use our formula. Future value, present value. Future value is equal to the present value multiplied by 1 plus r over 100k to the power of kn. Okay? So we know that it's asking for double. It says that she wants to double the amount she's invested. So that means that the future value is really 2 times the present value. And we can set up an equation using this formula. So I'm going to have 2 times the present value is equal to the present value times 1 plus r over 100 kn. Okay? So I'm going to rewrite it again. First of all, we can cancel the present values because they're being multiplied, right? So if I divide everything by present value, it cancels. So I'm going to have 2 is equal to, and then this part, remember, is part A, which is 1.056, okay? So that would be including the k exponent. And we would need to raise this to the power of n. And now we have to solve. So to solve, I can, for example, take the natural logarithm on both sides. So I'm going to have natural logarithm of 2 is equal to n natural logarithm of 1.056. Remember that we can take the exponents down as a coefficient when we apply the natural logarithm. And then to solve for n, we can simply divide. So natural logarithm of 2 divided by natural logarithm of 1.056. Okay, so this is the amount of years. All right, so let's look at our calculator. Okay, so natural logarithm of 2 divided by natural logarithm of 1.056, 12.7. Okay, so 12.7 years. Now be careful because the question is asking for find the year, and she's in 2020. So 12 years later is 2032. So if you just left 12.7 years, then you're wrong, right? It's 2032. Well, you're not wrong. You just don't have what they're asking for. So the year that she will reach double is 2032. So this is the way to do it by hand, but there's a way that we can just use the calculator to solve the same exercise. So let's look at the calculator way of doing it. We can go into apps. You're going to have a finance application. Okay, the first option, time value money solver. Okay, so N is the number of periods. We don't know. I is the interest rate, so it's 5.5. The present value, we don't know it, but we know that we want double. At the end, we want double the present value. So we can assume it's 1. And remember that we have to make sure we type in -1. Okay? So either the present value is negative and the future value is positive, or the present value is positive and the future value is negative. Remember that that has to do with whether money is coming in or coming out. Okay? So PMT is the payments. There's no payments, 0. Future value is 2 because it's double. Remember, double. Okay? So we start with 1. Okay? So I'm investing 1, so money is leaving my hand into the account. And at the end of the investment, I'm getting back double. So I'm getting back 2, and that's money that's coming in, and that's why it's positive. Okay? Negative when it's leaving your hand, positive when it's coming into your hand. Okay, the number of payments per year, you can leave it as 1, okay, because it's always at the end of the year. So they're only paying you once at the end of the year. And the compounding periods per year, we know it to be 4, okay? And the payment occurs at the end, so at the end of each year, okay? So now we want to solve for how many years. So you can hit alpha, enter to solve, and look at that, 12.6. All right, so it's not exactly the same because obviously when I did the calculation here, I used 1.056, which is an approximation. That number is rounded, but the calculator did it with all the decimals. So that's why we get a little bit of a different answer. But notice that it's basically the same, 12.6. If I round it, I would get 12.7, right? So the final answer is still 2032. So these are the two methods that you can use to solve this type of problem. It's really important for you to learn to use the time value money application in your calculator because it will save you a whole bunch of time. Of course, you can do it by hand. I did it by hand. It's not that difficult. It's not that long either. But notice that if you learn to use the calculator, it's just going to save you a whole bunch of time during your exam. All right, let's look at question number 2. The first two terms of a geometric sequence are u1 is equal to 2.1 and u2 is equal to 2.226. Find the value of r. So we know that u2 is just u1 times r. So u2 divided by u1 would be equal to r, which means 2.226 divided by 2.1 is r. Of course, we're going to have to plug it into our calculator. So we're going to go back to the regular mode, 2.226 divided by 2.1, 1.06. So that is 3 significant figures. So we don't need to round it. So 1.06, okay? Let's look at question number 2. Find the value of u10. All right, so we have to remember the formula for the nth term. We don't really have to remember it because it is in your formula booklet. Here it is, okay? But it's not a bad idea to know it because it might save you some time when you're solving these problems. So u10 would be u1 multiplied by r to the power of 9, right? N minus 1. Okay, there it is. So let's replace the things that we know. u1 is 2.1. r, we just found, is 1.06. And to the power of 9. So let's see what we get. 2.1 times 1.06 to the power of 9 is 3.5479, and this is where we really need to start rounding 3 significant figures. So 3.55, 3 significant figures. Okay, a lot of you had difficulty remembering that. Okay, and why do we round up to 55? Because the next number here is 7, so we have to round up. Okay, 3.55. All right, let's take a look at part C. Find the least value of n such that the sum of the first n terms is greater than 5,543. So there's again an easy way to do it and a hard way to do it. So let's do the hard way first. So S of n, or S sub n, greater than 5,543. So let's replace our formula, which again is in your formula booklet. You don't need to memorize it, although it's not a bad idea to memorize it if you can. After you do so many problems, you automatically start memorizing stuff. So 1 minus r to the power of n over 1 minus r is greater than 5,543. So let's replace our values. 2.1 is u1. 1 minus 1.06n over 1 minus 1.06 is greater than 5,543. So now, I'm going to solve this denominator part. So 2.1 times 1 minus 1.06 to the power of n over negative 0.06. Okay, greater than 5,543. So now to solve an inequality is just like solving an inequality. We have to isolate the letter. But remember that in inequalities, you have to be careful when you multiply or divide by a negative number. Okay, so in this case, we're going to multiply by 0.06 or negative 0.06. Okay, so 2.1 factor of 1 minus 1.06 to the power of n is less than, we have to flip the inequality because I multiply by a negative number. Okay, negative 0.06 times 5,543. Now we're going to divide by 2.1. So 1 minus 1.06 to the power of n is less than negative 0.06 times 5,543 divided by 2.1. So notice I'm not doing any calculations yet that require any rounding, okay? Because the idea is for you to round only once at the end of the problem. So you don't want to do a whole bunch of calculations in the middle, especially if they involve rounding. So for example, notice that I did this calculation, but that didn't require any rounding, okay? So it's okay to do that calculation. But if, for example, you have a calculation like you would get here, where you have a decimal that is infinite, or it has several decimal places that would require you to round, that's where little mistakes start to carry on in each step. So it's important only to round once, okay? So now, there's a couple of ways that we can continue with this problem. One of them would be to bring 1.06 to the right side, okay? And all of this is negative, so we can bring it to the left side by adding, or we can bring the this 1, subtracting 1 on both sides. So let's do that instead. So negative 1.06 to the power of n is less than minus or negative 0.06 times 5,543 divided by 2.1 and then minus 1. Okay? And now, to solve for n, I need to take the natural logarithm. But I have a problem. This is a negative number. And when I take the natural logarithm, it's going to give me an error. It's not going to work. So I need to multiply everything by negative 1. So 1.06 to the power of n, I multiply by negative 1, is greater than, again, flip the inequality because I multiply by a negative. That part is super important, okay? So 0.06, I got rid of this negative as well because I multiply by the negative 1, times 5,543 over 2.1, and then minus 1 becomes plus 1. Okay, now I can take the natural logarithm n times the natural logarithm of 1.06. Remember that I can bring the exponent down as a coefficient for natural logarithms, and then natural logarithm of, I'm just going to leave it like this. It's too long, I don't want to write it again. So n greater than the natural logarithm of this entire expression, and then divided by natural logarithm of 1.06. And this is where we can use our calculator to solve. Okay, so let's do the inside calculation first. So 0.06 times 5,543 divided by 2.1. Okay, I'm gonna add 1. All right, so that was the inside part. That was this part that I put in 3 dots, right? And then I have to take the natural logarithm of that. So natural logarithm of that answer. Okay, and I'm going to divide it by the natural logarithm of 1.06. Okay, notice that I'm not rounding. I'm using the answer from the previous step. I'm not rounding in like the middle steps. I'm keeping all the decimals. So that this gives me that n has to be greater than 87.03. Remember that n has to be an integer. In this formula, n is an integer. Okay? So what is the least value of n such that the sum is greater than, well, if is greater than 5,543? Well, if n has to be greater than 87.03, that means that the least value of n is 88. Okay, because it has to be an integer, and 87 would not be enough. All right, so this is one way to do it, which works, which is perfect. You can do it like this, no problem. There's another way to do it. All right. So another way to do it is to go into y equals, and we're going to write the formula for the sum. So 2.1 times 1 minus, in parentheses, 1 minus 1.06 to the power of x, because my functions here are in the variable x, over 1 minus 1.06. Okay, and I want to find x, right? I want to find x. So instead of graphing, I'm going to go to second table. All right, and these are all the values for the different x's. Okay. So remember, we want to be higher than 5,543. So this is an easier process, and it could be also a longer process. All right, it depends on how patient you are. You can go down until you get the first number bigger than 5,543. So this is 5,532. This is 5,866. So again, the answer is 88. All right. If you don't want to go down like this because maybe it's too long and it's whatever, you can go to table set and independent, in the independent variable, put ask, and you can simply start guessing until you find it. So you can do 30. No, that didn't work. So let's do 100. Okay, that's 11,000. So it needs to be less than 100. So let's try 70. And then 2032, let's try 80. 3,677, let's try 90. 6,000, so I'm over it. So let's try 89. I'm still over. Let's try 88. I'm still over. 87. Whoops, I'm under. So that's another way you can do it. That might be a little bit shorter. Okay. This basically by guessing into the calculator. All right. If you do it like this, which is an easier way to do it, make sure you write that process somehow. Make it visible for the evaluator what you're doing. So basically, you can put that y equals the function and that you did the table, and just show that you did the table. Show some process in order to get as many marks as you can. All right. And this is another way to solve this exercise that's probably a little bit easier. Okay, let's look at question 3. A group of 7 adult men wanted to see if there was a relationship between their body mass index and their waist size. Their waist sizes in centimeters were recorded on their BMI calculated. The following table shows the results. The relationship between x and y can be modeled by the regression equation y equals ax plus b. Write down the value of a and b. So one of the biggest problems that this exercise had was that a lot of people tried to do like the slope formula and find the equation of the line. The problem is that these numbers don't make a straight line. Okay, So that's why the problem is talking about modeling with a regression. You have to do the regression, not the equation of a line. Okay. So to do the regression, remember you're going to go into stat. You're going to go into edit one. So, and we're going to write the numbers. So 58, 63, 75, 82, 93, 98, 105. And then in the second list, we're going to write the y values. So 19, 20, 22, whoops, 22, 23, 25, 24, 26. So I'm going to go through it again to make sure that I didn't make any mistakes. 55, 63, 75, 82, 93, 98, 105, 26, 24, 25, 23, 22, 20, 19. All right. So now we're going to go into stat again. We're going to move to the right to calc. And we're going to come down to where it says linear regression. Okay. So what is the X list? List number 1. What is the Y list? List number 2. Is there a frequency list? No. Do we want to store it? It's always a good idea to try to store this. So we're going to store it. I'm going to click on vars. I'm going to go to the right to yvars. I'm going to click on function. And I'm going to save it in y1. Okay, so I want to store the equation in case that I need to use it. And then calculate. There are the values of A and B. Okay, so A is equal to 0.141. 3 significant figures. A lot of people put 0.14, for example. Or they put more numbers. 3 significant figures. Always round to 3 significant figures. That part is very important. A lot of you guys missed it. And B would be 11.1. Again, 3 significant figures. 3. Okay? So that would be part A. Part B is find a correlation coefficient. This part was interesting because some people did the slope and found the y-intercept. And then for the correlation coefficient, they actually got the right answer. But if you had the right answer for this, the A and B were right here. I don't understand. I don't understand what might have happened. But anyway, the correlation coefficient is 0.978. 3 significant figures. I cannot emphasize this enough. A lot of you left 977 rounded incorrectly, or 98, right? Or 1. I think one person even rounded it to 1. No, 3 significant figures. The next number is a 5, so we round up to 0.978. Okay, use the regression equation to estimate the body mass index of an adult man whose waist size is 95 centimeters. So, of course, all you have to do is take your equation and evaluate at 95. And we have the values of A and B. Okay, so this is one way to do it. All right, this is one way to do it. To evaluate, use your calculator. Another way to do it is remember that we saved the function here. So if I go to the table, I want to look at 95. There it is, 24.5. A lot shorter. 24.5. And again, rounding to 3 significant figures, 24.5. Okay, so let's look at question 4. The population of fish in a lake is modeled by the function f of t equals 1000 over 1 plus 24 e to the power of negative 0.2t for t between 0 and 30, where t is measured in months. Find the population of fish at t equals 10. So for that problem, all you had to do was find f of 10, right? Replace in the function t with 10. So obviously calculator, all right? Calculator. Now a lot of you might have like written a formula or whatever. What I recommend is always try to use the tables. Always try to use the tables. So 1000 fraction, okay, 1 plus 24 e to the power of negative 0.2 times x. Okay? Table. They're looking for the value at 10. 235.4. Okay, so 235, rounding to 3 significant figures. As always, rounding to 3 significant figures. Also, one thing to keep in mind is that they're talking about the population of fish, and there can't be 0.4 fish. That doesn't make any sense. So we're going to round to 235, okay? Find the rate at which the population of fish is increasing at t equals 10. The rate at which the population of fish is increasing. That's the derivative. That's the derivative. So we're going to go back outside, and we're going to use the calculator, all right? You can do the derivative by hand, but it's a long derivative. It involves like a denominator, so you can do the quotient rule, but that is a long rule. I really don't like that. Or you can turn it into like a polynomial with an exponent of -1 to bring the denominator to the top. So there's a couple of ways you can try to work that derivative, but remember that the calculator does everything for you. Okay, so the derivative with respect to x. Okay, remember that I already saved the function. So vars, y vars, the function, it's there, y1, when x is equal to 10. Okay, so this is the rate at which the population of fish is increasing. 36, rounding to 3 significant figures. 36. So it's really important to know how to use a calculator. All right, you don't have to do this derivative by hand. It's paper 2. All right, you're expected to use the calculator. Find the value of t for which the population of fish is increasing most rapidly. The value of t for which the population is increasing most rapidly. So basically, it's asking for what is the maximum of the derivative. What is the maximum of the derivative? We can solve that graphically. So we can graph, and I showed you guys this during class, you can graph a derivative. So here we can do, again, math, derivative with respect to x of y1, okay, and x equals x, and that'll graph the function. That'll graph the derivative. And we don't want to graph this one, so I'm going to unselect it so that I only look at the graph of the function. And remember that t goes from 0 to 30, so I'm going to adjust the window from 0 to 30. All right, and I'm going to, like at t equals 10, it was 36, so I'm going to adjust this y scale to like 100. Let's see if it works, and we're going to graph it. And there you can see a maximum. So we can do second trace maximum. All right, left boundary, right boundary, guess, just click enter. There it is. Okay, so let's read the question again. Find the value of t for which the population is increasing most rapidly. That's 15.89. If you round to 3 significant figures, 16. Okay, 16. or I'm sorry, 15.9. 15.89 rounded to three significant figures is 15.9. Sorry about that little mistake. 15.9. Again, so if this way of solving it is perfectly fine, make sure you write some process so you can put look at the graph of the derivative, maybe make a quick sketch in your answer booklet, and show that you did it in the calculator. Okay, of course there was other ways of doing it. You could have found the maximum of the derivative by finding the derivative of the derivative, then finding the critical points and determining if that critical point is a maximum or not. But imagine all of the calculations that you would have to do to find that. It's not easy. It's not short. So really, this point, you should do it with the calculator because you will waste a lot of time doing it by hand. Okay, so you're expected to use the calculator. All right, let's look at point 5. Let f of x equal the natural logarithm of x minus 5x for x greater than 0. Solve the equation f prime equals f double prime. So the derivative equal to the second derivative. So a lot of you did like the derivatives and tried to solve the equation. So I'll do that as well, but again, you can use the calculator. So you guys need to remember that you can use the calculator. So let's write the function natural logarithm of x minus 5x. Okay, so the derivative. So math, go down, derivative with respect to x. We're going to do vars, y vars function y1 with respect to x. That's the first derivative. And then the second derivative is just the derivative of the derivative. So I'm going to, again, math, go down to derivative with respect to x. So vars, y vars, okay, y2, which is the derivative. So this would be the derivative of the derivative. And you can do it x equals x, okay? And again, we're going to disable the first one because I only want to look at the first derivative and the second derivative. All right, let's set our window to standard and let's look at the graph. Okay, so there's an intersection point, and remember guys that precisely the intersection point is the solution. So second trace intersect. So first curve, you want to choose your first curve. Second curve, choose the second curve. Guess, just click enter. There it is. The intersection occurs at 0.558. Rounding to three significant figures. Three significant figures all the time. 0.558. So some of you that, a lot of you that tried to do it by hand didn't get the right answer. Some of you got the right answer, but got a negative answer as well. And you included both. However, x greater than 0. So you have to be careful because it wasn't a negative answer. The problem is setting the domain for x greater than 0. Even if they didn't give you this, you still have to assume it because the natural logarithm has a domain for it that is x greater than 0. You can have the natural logarithm of a negative number. Now, if you look at the solution, even the calculator knows to only graph positives because it knows that it's finding the derivative of a function that has a domain that is x greater than 0. So it was only the positive answer, okay? So how much time do you take doing it on the calculator? I don't know. It's 2 marks, less than 1 minute if you know what you're doing. If you try to do it by hand, so f prime of x. The derivative of 1 over, or natural logarithm of x is 1 over x. The derivative of 5x is 5. And then the second derivative, negative 1 over x squared, there it is. Okay? The derivative of 1 over x is negative 1 over x squared, and the derivative of a constant is 0. So the equality, 1 over x minus 5 is equal to negative 1 over x squared. Okay? And then a lot of you tried to use like logarithms to try to solve it, which was not correct. So what I'm going to do is multiply everything by x squared. Okay? Multiply everything by x squared. Okay, so x squared times 1 over x is x. Minus 5 times x squared, so minus 5x squared, and equals negative 1. X squared times 1 over x squared cancels, and I'm left with the negative 1. Okay, so I'm going to bring everything to one side. 0 is equal to 5x squared minus x minus 1. And then this, you can solve it using either the applications in the calculator. Okay, so there's a polyroot finder that you can use, polyroot finder, or the solver. I never recommend using the solver, or you can solve it graphically, or you can use the quadratic formula. However, look at all the work. If you're thinking about doing quadratic formula, it's still a whole lot of work and a lot of calculations where you can easily make a mistake. And also for, well, if you use the calculator methods for solving this, it would be best. But notice that you can use the derivative in the calculator itself, and it saves you at least 5 minutes, at least. So please keep that in mind for next time. All right, let's take a look at question 6. The following table shows values of natural logarithm of x and natural logarithm of y. The relationship between natural logarithm of x and natural logarithm of y can be modeled by the regression equation. Natural logarithm of y equals a times natural logarithm of x plus b. Find the values of a and b. All right, so the natural logarithm part is meant to throw you off. It's meant as a distraction. You can think of this as x1 and this is y1. So this would be y1 is equal to ax1 plus b. All right, it's the same thing. So part A is just doing the regression in your calculator. So let's take a look at the regression in the calculator. Stat, edit, let's erase, let's clear out the lists. Okay, so 1.1, 2.08, 4.3, and 6.03. Okay, it's only 4 numbers. All right, and y would be 5.63, 5.22, 4.18, and 3.41. Okay, so again, stat, move to the right calc, go down to the linear regression. The x list is L1, the y list is L2. I'm going to store it. Remember to always store because it could come in handy later, and then calculate. There it is. So find the values of a and b. A, and again rounding was a big problem here, is negative 0.454, rounding to 3 significant figures. And b is equal to 6.14, 3 significant figures. Okay? All right, use the regression equation to estimate the value of y when x equals 3.57. So here is the catch. They are not asking for natural logarithm of y. They're asking for y. Okay? But this regression equation is going to give you the value of natural logarithm of y. So how do you get y from natural logarithm of y? Remember, by raising to, or using e as a base for an exponent. So these two cancel. So when you get the prediction using your formula, then just use e to the power of natural logarithm of y. Okay, so let's go back to the calculator. All right, we saved it here. That's the regression line. I'm going to clear the rest of this stuff out. All right, and we can do the table. So what is the value of x? It says 3.57. So a common mistake would be to write 3.57. That would be a big mistake, because this regression in the equation is natural logarithm of x. So I'm going to do natural logarithm of 3.57. And I get 5.5648. All right. But that is natural logarithm of y. To get the final answer, I need to take this number and raise it to the and use it as an exponent with a base of e. Okay, so I'm going to store it. I don't think I can store it. Okay, let's see. Let's just use as many decimal points as I can. There's no way of storing this info, I don't think. So I'm going to copy the number. 5.564841045543, and that should be enough not to have any rounding problems. Okay, 5.564841045543. All right, and I'm going to use it here. Okay, so 5.5648, 5.5648, 5648, 648, 4104, 4104, 543, 543. 261, rounding to three significant figures. Okay, so the value of y is 261. A lot of you didn't do this step. Okay, so you plugged in natural logarithm of 3.57. A lot of you did that, and then plus b, but then you didn't realize that this is the natural logarithm of y. So to get y, you need to do e to the natural logarithm of y. Okay, so that was a little tricky part of that exercise. The relationship between x and y can be modeled using y equals kxn, where k is different from 0, n is different from 0, and n is different from 1. By expressing natural logarithm of y in terms of natural logarithm of x, find the value of n and of k. So, let's take a look at this. You can't do this part by in the calculator. You have to do it by hand, okay? So you have natural logarithm of y is equal to a times natural logarithm of x plus b. So I want y, not natural logarithm of y. I want y. So I'm going to raise everything. I'm going to use everything as an exponent with a base of e. So e natural logarithm of y is equal to e a natural logarithm of x plus b. On the left side, e and the natural logarithm are canceled, and I'm left with y. On the right side, I have, let's see, e times natural logarithm of x to the power of a, and you're going to see y in just a second. And then this plus b, remember you can split it as e to the power of b. Remember that? the sum of exponents, you can split it as a multiplication, okay? So what I'm saying is a to the power of b times a to the power of c is a to the power of b plus c. That's what I'm doing here. I'm splitting the sum as a multiplication. And I'm bringing the coefficient up as an exponent. Okay, so what happens with e and the natural logarithm of x? That is canceled. So you're left with x to the power of a and times e to the power of b. So the relationship between x and y can be modeled using a formula, okay, blah, blah, blah. By expressing, find the value of n and k. So what is the value of n? It's a. What is the value of k? K is e to the power of b. And remember that b, we found it in this part, 6a. So it's just taking that value of b and raising it to, or using it as an exponent. So you can do that on your calculator. So e, we're going to go to vars. We're going to use statistics. Okay. And the equation, b, here it is. 465 rounded to 3 significant figures. All right. So a, we have a from the first part, which is the same as n, and then k is e to the power of b. Okay, 7 and 8 were questions that you didn't have to do. So I took them out so that the exam wouldn't be 80 marks and it would be 71 marks, so that you would have the correct time to mark ratio for the exam. But I still recommend it for you to take a look at it after the exam. So I'm going to talk a little bit about question 7, and we're going to look at question 8. So question 7 is, consider the function f of x equals 48 over x plus kx squared minus 58, where x is greater than 0 and k is a constant. The graph of the function passes through the point with coordinates 4, 2. P is the minimum point of the graph of f of x. Sketch the graph of y equals f of x for x between 0 and 6 and y equals negative 30 and 60. Clearly indicate the minimum point where the x intercepts in your graph. So the first thing is we need to figure out what k is. So to figure out what k is, you're going to plug in the point and then isolate. You're going to plug in the point and isolate. So that would be f of 4 is equal to 2. So f of 4 is 48 over 4 plus k 4 squared minus 58. Okay, 48 divided by 4 is 12. Plus 16k minus 58 is equal to 2. And we have to isolate k. So I'm going to add 58. So 2 plus 58 is 60, is equal to 12 plus 16k. Then subtract 12. So 48 is equal to 16k. So 60 minus 10 is 50, minus 2, 48. And then divide by 16. So 48 divided by 16, maybe 3. 6 times 10 times 3 is 30. 6 times 3 is 18. Yes, 48. So k is equal to 3. You don't even have to do it by hand because you had the calculator. Okay, so the function is 48 over x plus 3x squared minus 58, which is a rational function. Okay, and then you have to do a sketch, which is easy. All you have to do is use the calculator. So I'm going to, and they even give you like the bounds for x and y. So y, I'm going to clear this out, and it's going to be 48 over x plus k, which is 3, x squared minus 58. And I'm going to set my window from 0 to 6 and my y from negative 30 to 60 graph. And basically it's copying this into your answer booklet. All right, you should always identify the intercepts. So they're asking specifically for the minimum, but you shouldn't just do the minimum, you should also do the intercepts. So there's no y-intercept, okay, but there's a couple of x-intercepts. So we're going to find all of them. So let's do the minimum first. All right, so we're going to have the minimum. So left boundary, right boundary, the guess, 1.999 repeating, all right, and y equals negative 22. All right, so it's basically at 2, comma, negative 22, okay? And the zeros, so second trace, 0, so the left, okay, so 8, 0.8, so it's close to 1. Remember, this is from 0 to 6, so 1, 2, 3, 4, 5, 6. So each one of those ticks it represents 1. So before 1, it should cross before 1. And second trace, well, yeah, let's do it, but it might not be that necessary. It looks like it's crossing 1, 2, 3 at either at 4 or close to 4. It's probably not exactly 4, but 3.9 something, so really close to 4. And you can do the sketch like this, identifying the minimum point. So at 2, negative 22. Okay. And then question 8. Question 8 was actually my favorite question in the exam. It's a shame that we didn't have time to do it, but two cyclists are at the same road intersection. One cyclist travels south at 20 kilometers per hour. The other cyclist travels west at 15 kilometers per hour. Use calculus to show that the rate at which the distance between the two cyclists changes is independent of time. Now, I gotta be honest with you, this is a hard question, all right? Because it's not obvious what they're talking about. So there's an intersection. The two cyclists are at the origin, at the intersection. One of them travels north at 20 kilometers per hour. So the first cyclist is traveling north at 20 kilometers per hour. Okay, and the other cyclist is traveling west. So this is north, this would be west. So we need to know our coordinates here. The other person is traveling west at 15 kilometers per hour. Okay, so use calculus to show that the rate at which the distance between the two cyclists changes is independent of time. So how do I know what how much distance these two people have traveled, at least from the origin? So I have the rate of change, which is 20, and I need to multiply it by the time. Okay, so I'm gonna make this a little bit prettier. So the distance is going to be 20t for this character. So the rate of the kilometers per hour times the number of hours, right? That would be the distance. And this character is going to have the same thing, okay? The distance this guy has traveled from the origin is 15t. That's the distance. Now I was talking about the distance between the two of them. So the distance between the two of them is this distance in a straight line. Okay, use your imagination here and imagine a straight line. So how would I find that distance? 15t squared plus 20t squared square root is equal to the distance. So 15 squared, I have no idea. I don't know. So I'm gonna do it like this. T squared, factor of 15 squared plus 20 squared. So I factored out the t. Well, 20 squared is actually not that difficult. Okay, so the square root of t squared is t, and the square root of this, so I'm going to do that in the calculator, plus (20 squared). Square root of 15 squared plus 20 squared. So it's 25. So the distance is 25t. Okay, and it says use calculus to show the rate at which the distance between the two cyclists changes is independent of time. The rate, so not the distance, the rate of at which the distance is changing. So that would be d prime, which is 25. Because when I find the derivative of 25t, that's 25. So the rate at which the distance is changing is 25. So this question is clearly a difficult question. It requires a good understanding of what it means to have a derivative, that what it means to or how to calculate the distance between these two people and how that relates to the time. It requires like a bunch of stuff that's not necessarily easy. Okay, it's a 5-mark question. I would probably think that it's even worth more marks than that. But this is how you would show that the distance is independent of time. Notice that it's independent of time because it's 25. It's not being multiplied by the time. So it doesn't matter what the time is. The rate of change is always 25. Okay? So that's the way to solve that question. All right, let's look at question 9. So contestants in a TV game show try to get through 3 walls by passing through doors without falling into a trap. Contestants choose doors at random. If they avoid a trap, they progress to the next wall. If a contestant falls in a trap, they exit the game before the next contestant plays. Contestants are not allowed to watch each other attempt the game. That sounds hilarious. Okay, so the first wall has 4 doors. With a trap behind one door, Ayako, I don't know how to pronounce that, is a contestant. Write down the probability that Ayako, I don't know, avoids the trap in this wall. So that she avoids the trap. So there's 3 good doors out of 4, so 3 out of 4, 75%. Natsuko, okay, they're killing me, is the second contestant. Find the probability that only one of Ayako and Natsuko falls into a trap while attempting to pass through a door in the first wall. So there's 2 possibilities. Either Ayako passes and Natsuko doesn't, or Ayako doesn't pass and Natsuko does. So that means that if Ayako passes, that's 3/4. If Natsuko doesn't, that's 1/4. So that's that probability. And I need to add it to the probability that Ayako doesn't pass and Natsuko does pass. Okay, which is basically 2 times 3/4 times 1/4, which is 2 times 3/4, which is 3. Or I'm sorry, not 2. 2 times 3 is 6. This is not 4. Sorry, this is 16. 6/16, and you can simplify that as 3/8. Okay, let's take a look at the next one. The second wall has 5 doors with a trap behind 2 of the doors. The third wall has 6 doors with a trap behind 3 of the doors. The following diagram shows the branches of a probability tree diagram for a contestant in the game. Copy the probability tree diagram and write down the relevant probabilities along each branches. So this one, so it falls into a trap. for the first wall, 1/4. Avoids, 3/4. We already knew that. Okay, remember that these always have to add up to 1. The second wall falls into a trap. So there's 5 doors and a trap behind 2 doors. So 2 out of 5. So that means this is 3 out of 5. And the last one has 6 doors and there's a trap behind 3 doors. So it's 1/2. Actually, I think in the mark scheme it actually says 3/6, but 1/2 is the same thing. So no problem there. All right, a contestant is chosen at random. Find the probability that this contestant fell into a trap while attempting to pass through a door in the second wall. So that means that he passed the first wall. So that means that if he passed it, that means the first probability is 3/4, and then he fell into a trap in the second wall. Okay, so 10/10. 3 times 2 is 6, and then 5 times 4 is 20. Okay, so 6 divided by 2 is 3/10. Okay, so he needs to make it past the first wall. That's the first probability, and then he needs to fall in the second wall. So that's the second, and we multiply. Okay, a contestant is chosen at random. Find the probability that the contestant fell into a trap. So if he falls into the first trap, that's 1/4. Plus, if he falls into the second trap, so that would be 3/4 times 2/5. Okay, so he makes it past the first door, doesn't make it past the second. Plus, 3/4, so makes it past the first, times 3/5 makes it past the second, times 1/2 doesn't make it past the last door. Okay, so these are the three possibilities. He either fails at the first door, fails at the second, or fails at the third. Okay, and you can calculate in the calculator or do it by hand as well. So 1/4 plus 3/10. I think this is the same probability as the last exercise. Plus, and then 3 times 3 is 9, times 1 is 9, and then 4 times 5 is 20, times 2 is 40. Okay, and here I'm going to multiply this by 10. I'm going to multiply this by 4. Okay, that denominator of 40. 10 times 12, 10 plus 12 is 32. Plus 9 is 41. Something is not adding up. Okay, 10 plus 12 is 22. That's what's not adding up. Okay, and then plus 9 is 31. So 31/40 would be 9E. There's another way of thinking about that problem that's in the mark scheme. It's actually a little bit shorter. So the probability that the contestant fell into a trap. So the complement is that he doesn't fall into any traps. So what's the probability that he doesn't fall into any trap? Well, he passes the first, passes the second, passes the last one, and then the complement would be 1 minus this. All right, so this would be the probability of not falling, or falling into at least one trap, or one trap. Okay, now the last question. 120 contestants attempted this game. Find the expected number of contestants who fell into a trap while attempting to pass through the door in the third wall. So what is the probability that the person falls in the trap in the third wall? Is 3/4, making it past the first, times 3/5, making it past the second, times 1/2, failing at the last one. So this is the probability that you fall into the last trap. And then to find the expected number of contestants, you multiply it by 120. Okay, Um, so this, I believe this was what, 31 over 40? No, sorry. Let's do the calculation. So 3 times 3 is 9, times 1 is 9. 4 times 5 is 20, times 2 is 40, times 120. So 120 divided by 40 is 3. So 9 times 3 is 27. Okay. All right, last question. A manufacturer makes trash cans in the form of a cylinder with a hemispherical top. The trash can has a height of 70 centimeters. The base radius of both the cylinder and the hemispherical top is 20 centimeters. Write down the height of the cylinder. So the radius is 20 centimeters, and this is half a sphere. So that means that this part is 20. So what is the height of the cylinder? It's 50. Okay, so find the total volume of the trash can. It's the volume of the cylinder plus the volume of half a sphere. So the volume of a sphere, which is in your data booklet, is 4/3 pi r cubed, and half would be 2/3 pi r cubed. And then just plug it into the calculator. There it is. If you round to 3 significant figures, it would be 79,600 to 3 significant figures. Okay. Okay, a designer is asked to produce a new trash can. The new trash can would also be in the form of a cylinder with a hemispherical top. This trash can will have a height of h centimeters and a base radius of r centimeters. There's a design constraint such that the height of the trash can plus 2 times the radius is 110 centimeters. The designer has to maximize the volume of the trash can, so it's a calculus problem. Find the height of the cylinder, lowercase h, of the new trash can in terms of r. All right, so what would be the height? It would be the height of the entire trash can minus r. Okay, but it's talking about in terms of r, so I don't need this h. So notice that I have this constraint. So h is equal to 110 minus 2r. So I'm going to replace that here. This lowercase h is 110 minus 2r minus r, which is 110 minus 3r. Okay, that is the height of the cylinder in terms of r. Okay, show that the volume of the new trash can is given by 110 pi r cubed. So this problem had a mistake in the question. The volume is not this. Okay, but still a few people got it right. So there was no way to get this answer. But if you did the work, I counted it. Okay, if you did it, even if you didn't get that answer, because it was correct. So the volume again is pi r squared h plus 2/3 pi r cubed, and r, or the height rather, is 110 minus 3r. So this would be pi r squared, and I'm going to replace the height 110 minus 3r plus 2/3 pi r cubed. So if you got up to here, I gave you the marks because this is correct. Okay. Of course, you can simplify this a little bit, so it would be 110 pi r squared minus 3 pi r cubed, 3 pi r cubed plus 2/3 pi r cubed. So again, you can simplify this part a little bit more and obtain some other answer. So let's do it. So I'm going to change this 110 pi r squared, and then this is going to be, I'm going to put the same denominator. So 9 over 3, which is equal to 3, pi r cubed plus 2/3 pi r cubed. Okay, and then negative 9/3 plus 2/3 is negative 7/3 pi r cubed and 110 pi r squared. So this was the correct volume. All right, but if you got up to this part, like replacing the h with the height and adding the two parts, then I gave you the full marks, okay? Okay, so using your graphic display calculator, find the value of R, which maximizes the value of V. So it's even telling you to use the calculator, right? So we're going to use the calculator. We're going to go into the functions. Let's clear this out. All right, the volume is 110 pi r squared. 110 pi x squared plus or minus 7/3 pi r cubed. All right, let's graph it. So let's try to change our window. Let's make this 0. Next, make this 200. Okay, so I'm not seeing a maximum, so let's try 50 and 500. So this is the problem with this calculator method. I think the volume before was like 70,000, something like that. Let's try 80,000. Whoa, it's still not big enough. So this is what is terrible about using the calculator sometimes. Let's try 100,000. Still not big enough. Incredible. All right, let's try, I don't know, 150,000. Okay, there it is. So you can see the maximum there. So using your graphic display calculator, find the value of R, which maximizes. I guess another way to do it was to like graph the derivative and see where it was 0. So I'm going to do that as well. So trace maximum. So here and here. Okay, so 31.4 rounding to 3 significant figures. So that's the radius, 31.4 to 3 significant figures. Actually, I did it like a not the smartest way. So let's try it again. Let's make this reasonable. 10. And instead of doing what I was doing, let's just graph the derivative. So that was not the smartest option that I made. So let's do the derivative. okay, of x. I want to derive the function that I have in y1 with respect to x. I only want to look at the derivative, so I'm going to unselect the first one. Okay, there it is. Okay, and remember that the zero of the derivative would be where there's a possible maximum. So let's look at the zero. Actually, I think I will need a couple negative numbers. So let's make this negative 10, like this graph. Just so that you can see that it crosses, and not just touches, but crosses the x-axis. So notice that the derivative is positive here and negative after. So that means that if it's positive before crossing the zero and negative after, it means it's going up first and then going down second. You can't really see the trace. So either way, it's not a good method. So let's see. Here, y is positive, so I'm going to click on that. Here it's negative, so somewhere there in the middle, it crossed. Okay, somewhere in the middle there it crossed. And then enter. So 31.4, same answer, okay? So it's not such a easy way to manipulate the calculator. So like the first way I did it, I just kept making the y bigger until I found the maximum, and you can find the maximum. Or if you draw the derivative, then you can also just look for the zero. And then if it's increasing before and decreasing after, that means it's a maximum, okay? So again, second trace, the zero. You can't really see it, but you can look at the y values. So this y value is positive, and the next one is negative, so I can choose that one. The next one is negative, and somewhere in the middle it should be the zero. Okay, and you get the same answer, 31.4. Alright, the last question. The designer claims that the new trash can has a capacity that is at least 40% greater than the capacity of the original trash can. State whether the designer's claim is correct. So, the original trash can was 70, oh, there it is. So I'm going to multiply this by 1.4. 40% greater means, one way to do it is to multiply 1.4. Or you can find 40% of that number and then add it, but it would be the same thing. Okay, that's not, let's do it like this. This times 1.4. Okay, so the volume of the trash can that the designer got should be at least 111,421. Okay, so we already found it here. So let's do the table. We know that the trash can is maximum when it's 31.4. 113 is the volume of the new trash can, and it says that it's at least 40% greater, and this is 40% greater would be 111. So is the designer correct? Yes, because 113,000 is greater than 111,000. So that would be the answer to the last question. And that's it, guys. So have a great vacation, and bye.